you for joining me. Welcome to TJ's Maths Clinic. Let's consider this question before us. We are asked to find angle x below. We have a diagram here, and this diagram is a circle with a tangent at A. We are asked to find this angle x. Of course, this is under circle geometry. Beauty of circle geometry, what can you see from the drawing? What can you see? Again, you have to recall as many theories as you can under circle geometry together with basic properties of angles. Let's look at how we can handle this together. What can you see from the drawing? From the drawing here, I can see a circle, then with isosceles triangle because of this sign. This sign means this triangle is an isosceles triangle. It means triangle BAD is an isosceles triangle. I can see a tangent at A as well. And I have many chords. I have chord A to D, A to B, B to C. I can connect C to D to have another chord like this. Okay? So there is no center here. Again, I can see this circle touches, I can see four corners touches this circumference, meaning at point A, D, C, B is touching the circumference at four corners, meaning I have cyclic quadrilateral here. An opposite angle of cyclic quadrilateral are supplementary. Very important. Again, if this is a tangent, the angle that chord A to D will make with the tangent will be the same with the angle that this A to C will make at the circumference. So here will be 63. In other words, I can say, let's write down the solution now. I can say angle T, the sign for angle, TAD will be the same with angle ACD, which is 63. Angle in alternate segments are equal. The reason is angle in alternate segments are what? Are equal. Equal. So this is the reason. Very important. Again, if we look at this very well, if we use chord A to B, if we use this chord, it means any triangle formed from that chord, the angle at the circumference will be the same. A to D to B, the angle here will be the same with B to C A, meaning this x here will be the same with whatever this angle is. Thus, angle from the same chord at the circumference are equal, or angle in the same segment are equal. So, again, this triangle here is an isosceles triangle. It means suppose this angle is y. This angle here will be y as well. Very important, because base angle of an isosceles triangle are equal. So we can deduce that angle BDA is the same as angle BAD. Base angles of an isosceles triangle are equal. They are equal. Very important. Again, if we use chord A to D, what can we see? A to D. A to D, we check. This is coming from the chord going into it. Again, this is coming from it going into it. It means the angle here will be 63 as well. Angle in the same segment are equal. We can conclude that angle ACD will be the same with angle ABD, which is equals to 63. The reason is angle in the same what? Segment are equal. Angle in the same segment are equal. Angle in the same segment are equal. Angle from the same chord or a triangle from the same chord will form the same angle at the circumference. Okay, which is 63. So it means the angle here will be 63 degrees. Okay, if we use chord A to D. This triangle is coming from the chord going into it. This one, that triangle is coming from the chord going into it. So a triangle from the same chord will form the same angle at the circumference. That is why we say angle in the same segment. Angle in the same segment are equal. Angle in the same segment, let me reframe it. Angle in the same segment, angle in the same segment, are equal. That's the reason. Or we can say a triangle from the same chord will form the same angle at the circumference. Very important. So we can easily find y. And whatever the value of this y will be the same as this x. Very important. If we use chord A to B, the triangle from that chord will form the same angle at the circumference, or the angle will be in the same segment. Very important. So it means we can easily find y now. Let's find y. It means y plus 63 will be equals to 180. So we can say y plus 63 will be equals to 180. Sum of angles in a triangle. So this is 2y plus 63 degree will be equals to 180. 2y now will be 180 degree minus 63 degree. So 2y will be equals to, our aim is to find the value of y, will be equals to 117 degree. Let's divide both sides by 2. Y now will be 58.5 degree. So if this y here is 58.5 degree, it means this x as well will be 58.5 degree. We have established the fact that angle BDA is the same as angle BCA. Angle in the same segment are equal. Angle in the same segments are what? Are equal. Equal. So we can conclude, let's conclude now that angle X is nothing but 58.5 degree. The angle here is the same thing with the angle here. If we use chord A to B, see the triangle here coming from that chord going into it, the angle that this triangle will form at the circumference will be the same with this other triangle. We have this triangle coming from the same chord going into the same chord. So the angle that they will form here at the circumference are the same. It means x is equals to y. So it means x is equals to y. And y is nothing but 58.5 degrees. So therefore, x is nothing but 58.5 degrees. So this will be the solution to this question. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.